In this video, we're going to go over a couple of examples of solving trig equations. All right, so in example one, we're given this equation here. Solve 2 sine of x minus 1 equal to 0. Give your solution in radians. No calc is required. Okay, so it says give your solutions in the interval 0 to 2 pi. Bracket 0 and then 2 pi open parentheses. So that's important to note later on. Okay, that's generally what you'll see when we're talking about trig equations. They don't generally include 2 pi within the domain of values. And then the second part is what are called general solutions, and we'll explain the difference between the what exactly a general solution means. Okay, so first, to solve the trig equation, okay, you need to isolate the trig function. So I just rewrote the equation here. So to isolate the trig function in this linear trig equation, we would add 1 and then divide by 2, right? Plus 1 to both sides here. And then we'll have 2 sine x equals 1. And then divide by 2, so you have sine of x equals a half. Okay. And what we would normally do here, in this case here, this is a unit circle value that you would know that you should recognize. But normally, if let's say this was not a unit circle value that we recognized, and we can find the value, okay, what we would do is take the inverse trig function of both sides. So what does that look like? What we would do if we were to take the inverse trig function on both sides, it would look something like this. So sine inverse, taking the sine inverse of both sides, sine inverse and sine on the left side will cancel each other out, and you're just left with x equals sine inverse of a half. And sine inverse of a half, you should recognize this again from the unit circle. Just had to fix that there. That occurs in quadrants 1 and 2 from the unit circle. So therefore, our solutions over 0 to 2 pi, that occurs again in radians at x equals pi over 6 radians. And remember, using the reference angle and by symmetry, it's pi over 6 above the x-axis, which is going to be at x equals 5 pi over 6. All right, so this is how this is what our solutions would be over the interval 0 to 2 pi. And then the general solutions basically means what are all of the possible solutions that we would have. So remember, sine, the function, right? If we were to graph it, it follows that sine curve, and we can continue to hit every 2 pi units after these first two answers, and that's exactly how we're going to write it up. So I noted that here. Basically, what the general solutions for a trig equation are basically all the coterminal angles with whatever your initial solutions were. Okay, so for this problem, it would be x equals pi over 6 plus 2 pi n, because sine is coterminal, or basically it's periodic every 2 pi units. And then we would do the same thing, 5 pi over 6 plus 2 pi n. So that way we can account for every single coterminal angle. We're going to make a note here. I just added this additional note here where n is any non-zero integer. All right, because if we think about it, right, if it was 2 pi over 6 plus 2 pi times 0, then our solution would be at x equals 0, but that's not true because sine of 0 does not equal a half. So, but if we were to go pi over 6 plus 2 pi plus 4 pi plus 6 pi plus 8 pi, that would be true. Or if we were to go in the opposite direction, pi over 6 minus 2 pi minus 4 pi would work as well. So that's why I made this note, n is any non-zero integer. And one last thing. So in part A, we were given an interval over 0 to 2 pi, but if there is no interval given, assume you give the general solutions, uh, meaning this here. Okay. That way you basically cover your bases for giving every possible solution. Okay. Um, all right. So taking a look at example 2, we're still solving an equation. It says solve the following equation, but it looks like we're using it's a different form. Okay, we have sine of x plus pi over 4 plus sine of x minus pi over 4 equals -1, and then it's over the interval 0 to 2 pi, 0 inclusive, 2 pi non-inclusive. Hint, use the sum and difference formulas to help you solve. So if we look at sine of x plus pi over 4, that's the sum formula, the sine sum formula from the previous section. And sine of x minus pi over 4 is the sine difference formula. Okay, and it's equal to -1. Now keep in mind that this is an equation. So therefore, because it's an equation, we can move terms over or cancel stuff out from one side to the other. So let's take a look at how we're going to do this. All right, so I label the parts here, A and B, so that way you can see when we're subbing it into the sum and difference formulas, how it's going to look, okay? So sine of x plus pi over 4 is this entire term here expanded. So using the sum formula, it becomes sine of x times cos of pi over 4 plus sine of pi over 4 times cos of x. That's all uh, using the sine sum formula. And then the second part here is the sine difference formula being expanded. So it becomes sine of x times cos of pi over 4 minus sine of pi over 4 times cos of x. And then equals -1. That hasn't changed. We haven't changed anything about that yet. Okay, so let's continue with this. And what we're going to see next is the fact that, well, there are unit circle values here that we can substitute and simplify to eventually get down to the final answer. So each one of these values, cos of pi over 4 and sine of pi over 4, I'm going to replace all of those with radical 2 over 2 and write them as coefficients if they're not already out, like, the first term out in front, okay? So I just replaced all the cos of pi over 4 and sine of pi over 4 with the radical 2 over 2. You could have also, if you kind of saw that there were terms that we can cancel out, like this sine of pi over 4 times cos of x minus sine of pi over 4 times cos of x. You can do it like that as well. But up to you in terms of how you want to solve it in order. And you should see after you sub in the unit circle values, radical 2 over 2 cos of x, negative radical 2 over 2 cos of x, they'll cancel out anyway. And what we have left here, we have radical 2 over 2 sine of x plus another radical 2 over 2 sine x. So we basically have 2 of the radical 2 over 2 sine x's, and they're equal to -1. Okay, so all we're doing essentially here is just combining like terms. So what happens here, the the 2's here will cancel out, and you're just with radical 2 sine x equals -1. And then we're going to isolate, just like what we did before, we're going to isolate the trig function, divide by radical 2 to both sides. Sine x equals -1 over radical 2. And this looks pretty familiar. We just have to rationalize this value. So this is equal to negative radical 2 over 2. Okay, so sine x equals negative radical 2 over 2. So if we were to take the inverse of both sides, sine inverse of negative radical 2 over 2. Luckily, again, this is a unit circle value. And because it's negative radical 2 over 2, that occurs in quadrants 3 and 4. So sine is negative in quadrants 3 and 4. So using pi over 4 as our reference angle, it would be pi over 4 units. We think about here, pi over 4 units below. So therefore, we're going to be at 5 pi over 4, because pi over 4 units below pi. And then on the negative x side, and then on the positive x side, we would be at x equals 7 pi over 4. Right. So those are our two solutions for example 2.